So this week we are working on rational and irrational numbers. This is new stuff. You might have heard about it in previous years. So you need to make sure to contact me if you have any questions, comments, or concerns. So let's get started with our first set of notes, lesson 1.
So we're going to start on Schoology, going to our Learning from Home folder. You're going to scroll down to the week of May 4th, 2020. This will be published when you guys are looking at it. And today I'm doing lesson 1 with you. And you are going to click on, it looks like an assignment. It is not officially an assignment. I'm not going to be collecting them to assess you, but I am able to look at them. So I can see where you're at with these notes. If you decide to do the video, I go along with you as we go through the notes. If not, I'm just going to be checking to make sure you're doing them and that you're doing them correctly. So you're going to click on that and it will take you to lesson 1 notes. I have to work off of a separate document so that it doesn't mess with people who have submitted. So lesson 1, we are working with rational and irrational numbers. So our learning target for today is I can define and identify rational and irrational numbers. So the first question asks, what is a rational number? Now you might have heard of rational and irrational before. You might call someone being rational or irrational based on if they're like making sense or not. It's kind of the same idea. So a rational number are integers, and integers are positive and negative whole numbers. Okay, so rational numbers are integers. They are also fractions, repeating decimals, and terminating decimals. So repeating decimals meaning they have that repetition, so like 0.555555, and it goes on forever. And terminating decimals, terminating means ending, so decimals that end. All of these numbers can be turned into a fraction. So if you have a calculator, if you have one of the scientific calculators from school, even better. So to check on your calculator, if something can be made into a fraction, you're going to press second PRB. There are other ways of doing it online, but it's honestly going to be the best option for you to have some sort of scientific calculator with that. So try to get one if you can. It's the one that we use in class is a TI 30X2S. So just hopefully you can find one of those for the purposes of doing this new learning. So that's a rational number. So an irrational number in the simplest terms are numbers that cannot be turned into fractions. So just keep that in mind, is like when we simplify an expression to its bare bones, it cannot, when you press second PRB, it's not going to work. So just keep in mind that not all long decimals are irrational. For example, if you type in 1 divided by 3 in your calculator, as you see, you get a repeating decimal. So it should be 0.33333333 going on forever. And then when you press second PRB, you should get 1/3. Therefore, it's a rational number because it was able to turn it into a fraction. Some other information and vocabulary that you need to know is a number that ends. A number that ends we call finite. Okay, some of you probably are saying finite is the first way you might think to pronounce it, but it's pronounced finite. And a number that goes on forever, repeating decimals included, so like 0.333 does go on forever, that's infinite. Okay, so we've got our first set of practice here. So it says write an I next to each number that is irrational and write a R next to each number that is rational. Additionally, write an F if the number is finite and an IN if it's infinite. So we're going to have a lot of letters here. So I'm going to do the first couple with you, and then you're going to try some on your own. So the first one is 5. So let's just think about this. So remember, a rational number is a number that we can make into a decimal. So can whole numbers be made into fractions? The answer is yes, they can. What do we put underneath it to make it into a fraction? We put a 1 underneath it. So this 5 can be written as 5/1. Therefore, it can be written as a fraction. So that means that this is a rational number, and 5 is just 5. There's no decimal, so therefore it is an ending number, therefore it is finite. Okay, so let's take a look at the next one. We have 1/2. It's already in a fraction, okay, and there's nothing to simplify within that fraction. 1/2 is 1/2. You can type it into your calculator as 1 divided by 2. You'll get 0.5, second PRB, and you got 1/2 again. So this is rational. And when we divide out 1 divided by 2, it's 0.5. That decimal ends. Therefore, it is finite. The next one is the square root of 2. Now, if you forgot how to type in the square root of 2 into your calculator, you are going, and again, I'm referencing the calculators that we use in class. You're going to press second x squared and then 2. The square root of 2, I'm going to tell you exactly what my calculator says. It says 1.41421356.2. It fills up the entire calculator screen. When that happens, that means it keeps going. Your calculator just cannot produce more numbers than that. And I don't see any pattern here. Okay, I'm just going to press second PRB to see if it turns into a fraction, and it gives me the same decimal back. That means it cannot be turned into a fraction. Therefore, this is an irrational number. And because it takes up my entire calculator screen and because there's no pattern, or not necessarily because there's no pattern, but because it takes up my whole calculator screen, it's going to go on forever. So therefore, it is infinite. All right, I want you to give D through G a try on your own. So what that means is I want you to pause this video right now and do them on your own, because when we come back, I'm going to jump right into the answers. So pause the video and do D through G. Okay, so you can check your answers with my answers here. The one I definitely want to go over is letter G. 10/3, already a fraction. So we know right away, and there's nothing to simplify within that fraction. So we know right away that it's rational. But if you type in 10 divided by 3 in your calculator, you're going to see in your calculator 3.33333. It fills up your whole calculator screen. That means it goes on forever. So it's infinite. So rational numbers can also be infinite. Okay, so the next part, it says determine if the number is rational or irrational. So taking a look, we've got a lot of different examples. And because I've been typing, my page has jumped down. So it's kind of strange. So I'm just going to enter down so it's all on one page. So what I want you to do, this is going to be independent. Again, we're going to pause the video, and then you are going to, actually, you know what? I'll do the first one with you. So we have 61 pi. There is a pi button in your calculator. Do not use 3.14 as pi, because that's not the exact number for pi. So we have 61 pi. So type in 61 pi into your calculator and press enter. So I see 191.6371519. Fills up my whole calculator screen. So that means that, well, it's not asking us for finite or infinite here, but just to double check, for this is definitely infinite, goes on forever, but the question doesn't ask that. So from your calculator screen, I'm going to press second PRB, and it comes up with the same fraction, or the same decimal, that same crazy long decimal. So this is irrational. Okay, I want you to go through and do the rest on your own. So pause the video, finish those problems, and then when we come back, you can check your answers. All right, I want you to check your answers with my answers. Remember, always just look for that fraction piece. Press second PRB. If it works, it's rational. If it doesn't work, it is irrational. And the last part, it says, in your own words, describe what rational, irrational, finite, and infinite numbers are. So since it says in your own words, I don't want to tell you exactly how to write this answer, but you can refer back to the front page here, and that gives you the definitions of rational, irrational, finite, and infinite. But I want you to make sense of it in your own words. Okay, so you can type it in the box here, and then you could submit your notes if you'd like me to look at them. If not, that's okay. I can still look at them partially completed. If you have a specific question, if you're not sure if you're correct or incorrect, shoot me an email or a Schoology message with your response. That's pretty much it for today's notes. Again, any questions or comments, please contact me. And I do require you to self-assess after you finish these notes. So I need you to go back to Schoology the week of May 4th. You can either access the week of 5-4 self-assessment right on the materials page of Math 8, or you can go to the specific lesson, today's plan, and it says self-assess right here. Once you click on that, it will take you directly to your self-assessment.